So far we've talked in general about sequences. I now want to be a little bit more specific and talk about what are called arithmetic sequences. So in an arithmetic sequence, the difference between successive terms is always the same. So that definition might be a little confusing, so I'll give some examples. So an example is 2, 4, 6, 8. Those are the even numbers. You'll notice that if you were to add 2 to each of these terms, you would get the next term. Another example is if you have like 5, 8, 11, 14, 17, and so on. You'll notice that each of these numbers is 3 more than the previous one. You just add 3 to get the next number for each of those. So these are examples of arithmetic sequence. Now, if you have something like, I'll give you some things that are not examples. If you have like 2, 4, 8, 16, 32, that's not an arithmetic sequence. It is a sequence because there is something happening to get from one number to another. You'll notice that for each of these, you may or may not notice, you're multiplying by 2. However, arithmetic sequence, you would have to add the same number each time. And then another example, like 1, 4, 9, 16, 25. These are all the perfect squares. That's a great sequence. However, it's not arithmetic because if you add something different each time to get to the next number. So for any real world examples, you're going to usually need a formula to actually do the example. And if you know that a sequence is arithmetic, you can actually use the following formula. So a sub n is equal to a sub 1 plus the quantity n minus 1 times d. In this equation, a sub n is the nth term. That's what we're actually finding the formula for. A sub 1 is the first term. And that value d is going to be what we call our common difference. And the common difference is going to be the distance between each number. So like for this example here, 3 was the common difference. For this first example, 2 was the common difference. So it's the distance between each number. Let's do some examples. For this first example, I have a starting term of 15 and my common difference is 4. We're going to be finding the formula for the nth term. What that means is I'm supposed to get something where I have a and equals. So honestly, with real life problems, you're not going to be given the first number and the difference. You're going to be given something more like you'll be given a list of numbers. You would be given like 15, and then the next thing would be 19, and the next thing would be 23, and so on. So that would be what it would look like. There are 2 ways that you can find this formula for this sequence. The easiest way to do it, I think, is probably using the formula, except that if you don't have the formula in front of you, I'll show you the more intuitive way of doing it so that you could just use your brain rather than using the formula. However, you're welcome to use the formula if you want to. So basically what I just need to do is just plug in numbers to this formula. I get a sub n is equal to a sub 1, which is 15, plus n minus 1 times my common difference, which is 4. And if you simplify that out, you get a sub n is equal to 4n plus 11. That is my formula for that. So if you have the formula in front of you, it's pretty easy just to do it that way. If you don't have the formula in front of you, I like just doing this in my head. I always remember that the number with my n is going to be my common difference, my d. And you'll notice that that's what for these values right here, they all go up by 4 each time. This 11 is actually, you can think of it as like the 0th term. almost. So this is the term that comes, if you were to go backwards from this sequence, if you were to go backwards 1, 11 would come before your first term. So you can think of that as the 0th term, which we would actually write as a sub 0. So that's another way that you can do this. This formula is not usually written in books, but I think it's easier to remember. But it would be just this right here, d times your n plus a sub 0. However, you don't usually have a sub 0, you usually have a sub 1. So you would have to get that on your own. So my second example, we are still finding a sub n. Sorry, I forgot to write that down. But in this one, you'll notice I have fewer things that might help me. I have to do a little bit of extra work before I do it. So I know my first term, it's -4. I do not know my second, my third, or my fourth term, but I do know that my fifth term is 16. So in order to do this problem, you first need a common difference. I need to figure out what number am I adding here to get between -4 and 16. There are two ways that you can do this thing. I want you to notice that I'm going up 4 times to get from my first to my fifth term. I move up 4 times. So one way to do this, we're going to be finding our d, by the way. That's our first step. So one way that you can do this is you can say, like, okay, I know that if I start with -4, I have to add d 4 times to get to 16. And then if you solve out this equation, you end up getting that d is equal to 5. That will give you your final answer. There's another way to find d. This is my first method. The second way to find d is to actually use that formula that I gave you at the beginning. And if I use this formula, I know A1, I do not know d, but actually I can solve for d. So what I can do with this formula, since I know what A5 is, I can set n equal to 5. So if I do that, I get A5, which is 16, is equal to A1, which is -4, plus n minus 1, which is 5 minus 1, times d. Then I will end up solving this out. You'll notice that this actually is the exact same thing as what I did for step 1. It's just a different way of thinking about it. So you'll find that this method, if you're having trouble understanding it intuitively, using the formula will always work. But I'm hoping that you kind of understand why we use that formula and where it comes from. So in the end, you do get d equals 5. Once you know that A1 is equal to -4 and d equals 5, go ahead, pause the video. I want you to find the rest of this on your own. So hopefully when you worked it out, I do want you to simplify it out, by the way. Hopefully you got 5n minus 9 for your final answer. So number 3 is actually pretty similar to number 2, except that I think it's a little bit harder. Just like number 2, I'm going to show you 2 methods. We do need to find actually 2 things. We need to find d and we need to find A1 before we can actually write our formula for it. So to find d, you can either use the formula, but it's really complicated if you do that, or you can try to think about it using logic. So if you think about it using logic, I want you to keep in mind that you must add your d 5 times to get from your 5th term to your 10th term. I got that 5 by doing 10 minus 5, and the 10 and the 5 come from these values. So what we have is we have 190 plus 5 times d is going to give me 115. This will give me my value of d. And when I solve that out, I end up getting that d is equal to -15. So notice how I started, my 5th term is actually higher than my 10th term, which means that my d is negative because I went lower. So now that I have my value for my common difference for my d, there's 2 ways that you can find your first term. The first way to find the first term is by keeping in mind that to get from A1 to A5, I am adding negative 15 4 times. I'm going to go ahead and do that. So I know that to get from A1 to A5, I do 4 times negative 15. I added negative 15 4 times. That gave me 190. And if I work that out, I get that A1 is equal to 250. So once you have your first term and your common difference, you can actually write your equation. Go ahead, pause, and do it on your own. So hopefully you ended up getting A sub n is equal to negative 15n plus 265. Now I will tell you, I'm going to show you the second way to do this. I'm not going to work the whole thing out. So the second way that you can do this type of problem is to use that first equation that I gave you. And this is good if you're really having trouble understanding what I just did, I would do it using the equation. Although I do recommend that you try to understand what I did for the first one. I think that way, if it makes sense to you, I think that's probably a better way to do it rather than just trying to remember a formula. So the way that you can do it using this formula is you can say n equals 5, and you remember that so we have a sub 5, which is 190, is equal to a sub 1, we don't know that, plus my n, which is 5, minus 1 times d. And then I would have a second equation when n equals 10. That would give me 115 is equal to a1 plus 10 minus 1 times d. If you solve out that system of equations, you will get the same values for A1 and D, and that will give you your final answer. You do get the same answer this way. So for this problem, I want you just to take a look at it. You can pause for maybe a minute. See if you can find a faster way to find the sum of this that doesn't involve typing every single thing into your calculator or doing every single thing by hand. Okay, so the little trick for this one is to notice that this actually, there is a pattern here. Each of these is separated by 2. If you add together 1 and 19, you get 20. If you add together 3 and 17, you also get 20. Same thing, this gives you 20, this gives you 20, and this gives you 20. So you actually have 5 sets of 20, which would give you 5 times 20 equals 100. So that's the little trick if you see something like this. I'm going to actually give that to you as a formula. So this thing that we just found the sum of is what we call a finite arithmetic sequence. So we've already talked about what an arithmetic sequence is. A finite is actually the opposite of infinite. Finite means it ends, so it has an ending point. So my last value of this is 19. Occasionally, you'll see something that just like goes on. It has a plus and then dot, dot, dot afterwards. That's what happens when you have an infinite sequence being added together. But finite means it has an ending or it's not infinite. So the sum of a finite arithmetic sequence is going to be written out with this formula right here. So it's S sub n is equal to n over 2 times my first term a1 plus my last term an. And n is equal to the number of terms. So I do want you to notice that we actually use this formula up here. You might not have realized that you used it, but in this thing, I had a total of 10 terms. That was my n. I did n divided by 2, which was 5, so n over 2. And my first term was a1, it was 1. My nth term, my last term, was 19. 1 plus 19 is 20. So that's actually the formula that we have. So you will find that using this method, actually using the method that I used in number 4, actually works pretty well for when you have a small number of values in your sum. The problem is going to come when you have more values. So let's say we have like 2 plus 4 plus 6 all the way up to 100. So this is a pretty big sum. There's a lot of stuff. This is every even number up to 100. And so I want you to notice that the number of terms, my n, is going to be 100 divided by 2. It's 50. My first term, a1, is equal to 2. My nth term, my last term, is equal to 100. Keep in mind that since n is 50, this is also, you can also think of that as the 50th term, but we tend to call it the nth term. So then you're just going to use your formula. My sum, this thing, by the way, means S of 50 means the sum of the first 50 terms of this sequence, so if it were to keep going on, or you can just say it's a sum of a 50-term sequence. Either way works. So it's just going to be 50 divided by 2 times 2 plus 100, and your answer is going to be 2,550. So this formula is actually going to work really well with any arithmetic sequence where you are actually given summation notation. So keep in mind that I'm using I instead of n. If it makes you feel more comfortable to rewrite these things with the number n, you can do that. This right here, this n, is my nth term. So basically this is saying I'm adding 1 plus 2 plus 3 plus 4 all the way up to 25. So I can see that I start at 1, I go to 25. My value of n overall is 25. My first term is just going to be 1. My nth term, my last term, is going to be 25. You can do this problem the same way that you did the previous one. So we find that the sum of our 25-term sequence is going to be 25 over 2 times 1 plus 25, and that gives me 325. So this example, I can't take credit for it. My husband actually created it. He's really into video games. So here we have a giant upside-down triangle being constructed. On the bottom of the triangle, there's one block followed by 3, then 5, and so on. So like we have 1, 3, 5, 7. It keeps on going until you get to the 80th row. There's going to be quite a few blocks in the 80th row. We want to know how many blocks are needed in the triangle altogether. Go ahead, pause the video, give it a try, see if you can figure it out. Okay, so the first thing on this one I want you to notice is that we have a total of 80 blocks, or we have a total of 80 rows. The second thing we know is that our first term is 1. The last thing that we need in order to figure out the sum is our nth term, or our 80th term. That we don't know, but in order to find that, we have a few different options. I am going to find it by writing the formula for my nth term. You can find it whatever way works best for you. So the formula for my nth term, I know that each of these goes up by 2. My common difference is 2, so I get 2n. And then you can use the formula, or you can just find, I always like to find the 0th term, which would be the term that comes before the first one. It would be minus 2. So then my 80th term is going to be 159. Once you have that, you are just going to be finding the sum of all of the terms between 1 and 159. You can either just find the answer, or I'm going to show it to you using summation notation, just so you kind of see what that sum looks like. I think that's an important thing to know how to do. So I'm going to start at n equals 1, and I'm going to end at n equals 80. And what I'm doing is I am finding the sum of all of the terms of this series. You're welcome to write out the first few. If you do, you'll notice that it's 1 plus 3 plus 5. It just keeps on going. But I recommend that you just use that formula. It's the easiest way to do it. So we know we have 80 terms. We do 80 divided by 2 times my first term plus my last term. And this gives me 6,400 blocks.